Welcome to Foundations of Math 30, outcome 30.05. This is lesson number 3, multiplication of probabilities involving independent events. Okay, so independent events are two events where the happening of one event in no way influences the second event. So for example, tossing a coin and rolling a die are independent events. If I have dependent events, then the outcome of one thing affects the outcome of the other thing. Okay, those are considered dependent. And for any two independent events, the probability of both A and B, so here we're doing an AND question, so it's the intersection of probability A and B, and we kind of already know this, that the word AND means to multiply. So I'm going to multiply those two probabilities together. So let's just go ahead and look at some examples of this. So one card is drawn at random from a standard deck of 52 cards and returned to the deck. Okay, so I pick a card, put it back to take another card. Find the probability of drawing 2 red cards. So the first event does not affect the second event because you return the card to the deck. So basically what I want is to get a red and then a red again. So that's going to be the probability of getting a red the first time multiplied by the probability of getting a red the second time. So out of my 52 cards, 26 of them are red, and I put that card back in the deck, so there's still 52 in the deck, and there are still 26 red ones. That comes out to be a half times a half, which is 1/4. Okay, the probability of getting 2 aces, so I want to get an ace and then an ace again. So it's just the probability of getting an ace times the probability of getting an ace again, right? So it's going to be 4 to 52 times 4 to 52, because I put the card back, so there's no difference on the first time as compared to the second time. So 1 out of 169 when I reduce that fraction. The probability of getting an ace and then an 8, well, out of the 52 cards, the probability of getting an ace is 4. Then I need to get an 8, so I put it back, so there's still 52. There's 4 8s. So this reduces to 1/13 times 1/13, which is 1 out of 169 again. The probability of getting an ace and an 8 in any order. So what that means is that I can get an ace and then an 8, or I can get an 8 and then an ace. Okay, so remember that the word or means I'm going to add them together. So the probability of getting an ace and then an 8, well, we've already done that. It's 1 out of 169. We just did that. Plus, well, an 8 and an ace is going to be the same thing again. So this is 2 out of 169. Okay. Let's take a look at number 2. It says we're rolling a dice 3 times. Find the probability of rolling a 6 each time. So basically I want to get a 6 and then a 6 and then a 6 each time. So these are independent. What I roll the first time has no effect on the second time, and so on and so on and so on. So this will be 1/6 times 1/6 times 1/6 is equal to 1 out of 216. The probability of never rolling a 6, so that means no 6 and no 6 and no 6. Well, if it's not a 6, it means you're going to get a 1, 2, 3, 4, or 5. So it's 5/6 times 5/6 times 5/6 is 125 out of 216. And then the probability of rolling at least 1 6. Okay, so this scenario, what we just found in B was never rolling a 6. So kind of the complement of that would be rolling a 6 at least once, right? So it'd be 1 take away 125 out of 216. So that gives me 91 out of 216. And the probability that each roll is a number less than 5, right? So less than 5 and less than 5 and less than 5. So that means I'm going to get a 1, 2, 3, or 4. So that's 4/6 times 4/6 times 4/6, which in reduced form is 8 over 27. Again, just grab those calculators, put those fractions in there. Remember that if you don't have a calculator that does fractions, you could definitely give these answers as decimals if you wanted to. If you prefer to work in decimals, this would be 0.296. Okay. Let's look at this example. It says 99% of computers manufactured in a plant have satisfactory keyboards, okay, and 96% have satisfactory monitors. If you purchase a computer, consider the following, okay? So this is asking about satisfactory and unsatisfactory. So I'm just going to get the information kind of maybe off to the side over here to help me out. So let's talk about the keyboard. What I know is that the probability that it's good is 99%, or 0.99 if I was dealing with probability as a decimal. The probability that it's no good would then be 0.01, right? Because it's either good or it's no good. And then the monitor, the probability that it's good is 0.96. So then the probability that it's no good would be 0.04. So the probability that I get a satisfactory keyboard, so I want to get a good keyboard and a good monitor, right? So that's going to be the probability that I get a good keyboard times by the probability that I get a good monitor. That's a little check mark there, by the way, not a B. So the probability of getting a good keyboard is 0.99 and a good monitor is 0.96. So 0.99 times 0.96, maybe I'll use this instead since there's a decimal there, will give me 0.9504. Okay, a good keyboard and a not good monitor, right? A good keyboard, but a not good monitor. So the probability of getting a good keyboard and a crappy monitor is the probability of getting a good keyboard multiplied by the probability of getting a crappy monitor. So my probability for a good keyboard is 0.99. My probability for a crappy monitor is 0.04. When I multiply those together, I get 0.0396. All right, I kind of like this stuff. It's not too crazy. The probability of getting a crappy keyboard, an unsatisfactory keyboard, and an unsatisfactory monitor. So I want the probability of getting a crappy keyboard times by the probability of getting a crappy monitor. Crappy keyboard, 0.01, times crappy monitor, 0.04, gives me 0.0004. So very unlikely that you're going to get both of them crappy. Okay, just to make sure you're still awake here, the probability of getting a good keyboard or a good monitor. Okay, one or the other. So remember that our OR formula is then the probability of getting a good keyboard plus the probability of getting a good monitor, subtract the probability of getting both good keyboard and good monitor, right? That's our formula from the first part of the unit. So the probability of getting a good keyboard is 0.99. Probability of getting a good monitor is 0.96. Now, if you were doing this question and you forgot about this part, hopefully you would pick it up here that you made a mistake, because when you add these together, it's over 1, and we know that the maximum probability can only be 1. So I need to subtract this amount. Well, and I mean, you can recalculate this if you want, but up here we already did it. We calculated the probability of getting a good keyboard and a good monitor is 0.9504. So I'm going to subtract 0.9504. So that ends up giving me 0.9996. So very highly likely that you will get at least one or the other. All right, let's move on to this one. It says, on average, the Huskies defeat the Pronghorns 3 out of every 5 games. So they win 3 out of every 5. Find the probability that in the next 10 games, the Huskies will win them all. So basically what this is saying is the probability of getting a win, and then a win, and then a win, and then a win 10 times, right? So what that means is I'm going to take, what's the probability of getting one win? Well, that'd be 3/5. So I would be going 3/5 times 3/5 times 3/5 times 3/5 10 times. So I mean, you can write it out 10 times if you want, but the shortcut would be 3/5 to the power of 10. And when I put that in my calculator, it's 0.00605. I'm just going to make it as a decimal because those are huge numbers that are kind of ugly if I write them down. The probability of losing them all, so again, it'd be a loss and a loss and a loss 10 times, right? So if I win, the probability of winning is 3/5. The probability of losing is 2/5 to the power of 10. So that comes out to be 0.000105. The probability that you win the first 7, so I'm going to win, oops, this is the problem when they're big. 7 times, 1, 2, 3, 4, 5, 6, 7, and then I'm going to lose 1, 2, 3. Okay, so what is that? My probability of winning 7 times multiplied by my probability of losing 3 times. Okay, and if I calculate that, I get 0.00179. Okay, so these ones aren't too bad. Just remembering that the word and means to multiply or means to add. So you can go ahead and work on the practice questions now.